got asked some good questions there on the proof by induction. So hopefully this video will help clear that up. And if not, ask more questions. I think step 1 and step 2 are okay. It just seemed to be maybe step 3. So step 3, you're going to prove the proposition is true for n equal to k plus 1. So anywhere you had an n, you need to replace it with k plus 1. And this is where, like I said, if I push the 6th domino, I need to know the one after it will fall. If I physically push the 10th domino, I need to know the one after it will fall. So this is what I'm doing here. Now, this is what I'm trying to prove. So anywhere I saw an n, I replaced it with a k plus 1. And I need to prove that this is divisible by 3. I don't know that that's divisible by 3. Look, like for me looking at it right there, I haven't a clue. So I'm going to try and rewrite it. So I rewrote it like this. Is that line, sorry, now I'm just going to ignore this. Is that line exactly the same as that line? Yeah, I know from my rules of indices I can do that. All I've done here is replaced 10 to the power k with what I know it's equal to from my step 2, from my assumption. So is this line exactly the same as this line? Yeah, it is. And then I just kept going. I still don't know if this line is divisible by 3. You can check every single line as you're going. Is this now divisible by 3? Don't know. Is this line divisible by 3? Don't know. So I keep going and I get to here, I just multiply it out. Is this line divisible by 3? I still don't know. Now, you could get to here and go, yeah, this line is divisible by 3 because 3 goes into this number here, 30a, and 3 goes into this number here. So maybe that last line there isn't necessary for you. But all I did was for my last line, I took the 3 out in common, and 3 times anything is divisible by 3. Like, think about it, 3 times 7, divisible by 3. 3 times 20, divisible by 3, because a 3 is there. And it has to be a whole number that it's, that it divides into. So to be divisible by 3, 3 into 21 goes 7 times. So it's a whole number. So definitely, this is divisible by 3. Because I can take my 3 out in common. Now, if this line is divisible by 3 and it's the same as this one, then this is divisible by 3. If this line is the same as this one and this one I'm saying is divisible by 3, then this one's divisible by 3. If this is the same as this one must be divisible by 3. If this is the same as this must be divisible by 3. And if this is the same as this is divisible by 3. So I can explain for myself. The very last thing here is that 10 to the power of k plus 1 minus 7 to the power of k plus 1 is divisible by 3. And then I go on to my step 4 and just, since the proposition is true for n equal to 1, and assuming it's true for n equal to k, I have now proven that the proposition is true for n equal to k plus 1 for all n an element of natural numbers.